Welcome to the Bedtime Lab, where we gently drift into the world of wonders and curiosities. I'm so glad you're here with me tonight as we embark on a celestial voyage to explore the mysteries of Jupiter's Great Red Spot. It's a place where the imagination can truly wander, and I hope you'll find comfort and intrigue in every fact we uncover. Before we begin, I'd love to hear where you're joining us from. Feel free to share your location in the comments, and let's create a constellation of listeners from all around the world. Now, imagine a storm so vast and fierce that it has been raging for centuries. This is the Great Red Spot, a giant storm on Jupiter that has been capturing the fascination of astronomers and dreamers alike. Let me share something intriguing. The Great Red Spot is so large that it could comfortably fit our entire Earth inside it, not just once, but up to 1.5 times. Can you picture that in your mind's eye? Speaking of size, the Great Red Spot stretches approximately 16,000 kilometers across. To put that in perspective, that's more than 1.5 times the entire width of our own planet. It's a swirling mass of clouds and winds, constantly churning in a dance of cosmic proportions. And here's something fascinating. The winds within this colossal storm reach speeds of up to 430 kilometers per hour. That's faster than the most powerful hurricanes we experience here on Earth. Yet from a distance, it seems so serene, a gentle reminder of the power hidden beneath the surface. Did you know that the Great Red Spot has been observed for over 350 years? It's true. First noted by astronomers in the 17th century, it has persisted through generations, a timeless tempest in the vastness of space. As we continue our journey, consider this. The beautiful red hue for which the storm is named remains somewhat of a mystery. Scientists debate the exact cause of the color, speculating that it might be the result of complex chemical reactions involving elements like sulfur and phosphorus. Isn't it intriguing how even the most enduring phenomena of the universe can hold secrets yet to be uncovered? Now, let's delve a little deeper. The Great Red Spot is not only a sight to behold, but also a testament to the dynamic atmosphere of Jupiter. The storm is confined by jet streams that act like invisible walls, keeping it spinning in place for centuries. Imagine the persistence and strength it would take to remain unchanged for so long. Many have wondered if the storm might eventually dissipate. Observations suggest that the Great Red Spot has been slowly shrinking over the past few decades. In the late 1800s, it was estimated to be over 40,000 kilometers wide. Today, it is less than half that size. Will it disappear, or will it find a way to endure? Only time will tell, but the mystery adds to its enigmatic allure. Here's another interesting thought. While we often focus on the Great Red Spot, Jupiter itself is adorned with many such tempests, though none as magnificent. The planet is a tapestry of swirling storms and fleeting tempests, each contributing to the vibrant and ever-changing face of this gas giant. And speaking of Jupiter, did you know that this majestic planet is more than just a stage for storms? It plays a crucial role in our solar system, acting as a cosmic shield of sorts. Its immense gravity helps to capture or deflect asteroids and comets that might otherwise threaten the inner planets, including Earth. Isn't it comforting to think of Jupiter as a guardian in the night sky? Let's return to our swirling storm. The Great Red Spot, with its swirling clouds and powerful winds, is a natural laboratory for scientists. By studying its movements and changes, we learn more about atmospheric dynamics that can even apply to our own planet. It's a reminder of how interconnected we are with the cosmos, learning from the storms of Jupiter as if they were our own. And here's a delightful tidbit. The Great Red Spot can sometimes change color. Observers have noted that its hue can vary from deep red to pale pink. These subtle shifts are yet another puzzle for scientists to ponder. Lastly, in this gentle exploration, let us appreciate the great red spot for its role in igniting the spark of curiosity. It stands as a symbol of the mysteries that await our understanding, inviting us to look up and wonder. As we drift off into slumber, wrapped in the comforting embrace of these cosmic stories, let the great red spot be a reminder of the beauty and power of the universe we call home. Thank you for joining me tonight in the Bedtime Lab, and may your dreams be filled with stars and swirling clouds. As we continue our celestial journey, let me share with you another captivating aspect of Jupiter's great red spot. Did you know that the storm is actually an anticyclone? This means that the winds within it rotate in a counterclockwise direction in the planet's southern hemisphere. Just imagine a storm where everything moves against the usual flow, creating a mesmerizing spectacle in the gas giant's vast atmosphere. Here's another intriguing detail. The Great Red Spot is located approximately 22 degrees south of Jupiter's equator. This position is relatively stable, allowing the storm to remain in this location for centuries. Isn't it fascinating how this enormous tempest has found its niche on such a colossal planet? Speaking of Jupiter's colossal size, let me tell you something truly astonishing. The Great Red Spot is taller than Earth's highest mountains. The storm's clouds extend about 8 kilometers above the surrounding cloud tops. To put that in perspective, Mount Everest rises just under 9 kilometers above sea level. Picture that towering storm cloud reaching high into the Jovian sky. And did you know that the temperatures within the Great Red Spot are quite extreme? The upper clouds of this swirling tempest are cooler than their surroundings, with temperatures dipping to about minus 160 degrees Celsius. It's a chilly world up there, a stark contrast to the storm's powerful warm heart. Here's a delightful fact about the dynamics of the storm. Researchers have discovered that the Great Red Spot's shape is constantly changing. Observations reveal that the storm can appear more oval or round at different times. These fluctuations in shape offer scientists clues about the inner workings of this mighty storm, and it's an ongoing mystery that continues to intrigue. It's also worth noting that the Great Red Spot is not just a single layer of clouds. This swirling vortex is a complex structure, with multiple layers interacting with each other. Each layer contributes to the storm's overall appearance and behavior, like a cosmic ballet of gases and winds. Speaking of appearances, Jupiter's Great Red Spot isn't the only great spot in our solar system. Neptune, another gas giant, has a similar storm known as the Great Dark Spot, which was observed during the Voyager 2 flyby in 1989. These storms, though on different planets, share similarities that offer valuable insights into the atmospheric processes elsewhere in our solar system. Did you know that Jupiter's Great Red Spot has experienced turbulence in recent years? The storm occasionally sheds fragments, creating smaller, short-lived storms around its perimeter. These flakes or blades of the storm demonstrate how dynamic and ever-changing this celestial phenomenon truly is. And here's an interesting connection to our planet. The study of the Great Red Spot has helped scientists develop better models for understanding Earth's own weather systems. By observing how Jovian storms interact within Jupiter's atmosphere, researchers gain insights into complex meteorological processes that can be applied to our own atmospheric studies. Have you ever wondered how scientists observe the Great Red Spot from such a great distance? It is through the use of powerful telescopes both on Earth and in space. Instruments like the Hubble Space Telescope allow astronomers to study the storm in incredible detail, capturing its swirling clouds and vibrant colors for all to see. The Great Red Spot's persistence is not only a marvel, but also a challenge to scientists. While many storms on Jupiter come and go, lasting only a few years, this ancient tempest has defied the odds by persisting for centuries. Its longevity offers clues about the unique atmospheric conditions on Jupiter that allow such a storm to endure. And here's a curious thought. Despite being a storm, the Great Red Spot can sometimes appear peaceful and calming when viewed from afar. Its swirling patterns have an almost hypnotic quality, reminding us of the beauty that can be found in the most powerful forces of nature. Did you know that the Great Red Spot can influence storms elsewhere on Jupiter? Its presence affects the flow of the planet's atmosphere, creating disturbances that can lead to the formation of other storms and cloud bands. It's as if this giant storm is orchestrating a symphony of atmospheric activity across the planet. Lastly, let me leave you with a thought about the future. As we continue to study Jupiter's Great Red Spot, new technologies and missions, like those from the Juno spacecraft currently orbiting Jupiter, promise to unveil even more secrets of this enigmatic storm. Each discovery brings us closer to understanding not only this incredible feature, but also the broader mysteries of the universe. As we drift deeper into the realm of slumber, let these surprising facts and the dance of the Great Red Spot guide your dreams. It's a reminder that even in the vastness of space, there are wonders waiting to be discovered. May your mind wander through the swirling clouds of Jupiter as you rest, and let the cosmos inspire your imagination. Here's an intriguing thought. The Great Red Spot isn't just a spectacle of swirling clouds, it's also a richly colored marvel. The storm's iconic reddish hue doesn't come from the usual suspects. Scientists believe the color might result from complex chemical reactions between ultraviolet light from the sun and elements in Jupiter's atmosphere, such as ammonia and acetylene. These reactions could create compounds that give the storm its crimson tint. Isn't it fascinating how the cosmos finds unique ways to paint its masterpieces? On that note, the size of the Great Red Spot is another feat of cosmic engineering. At its widest, it spans more than 15,000 kilometers, which is large enough to swallow Earth whole. Imagine our entire planet fitting into a storm on another world. It's a humbling perspective on the vastness of the universe and the scale of phenomena it contains. Did you ever wonder about the speed of the winds within the Great Red Spot? They are truly astounding, reaching up to 430 kilometers per hour. That's faster than the strongest hurricanes on Earth. The sheer power and energy within this storm remind us of the raw forces at play in our solar system, far beyond anything we experience here on our home planet. The Great Red Spot is not only a marvel in terms of its longevity and size, but also in how it interacts with its surroundings. It acts almost like a cosmic lighthouse, affecting the patterns of the cloud belts that encircle Jupiter. This complex interaction influences the weather systems of the entire planet, demonstrating how interconnected and dynamic Jupiter's atmosphere truly is. Speaking of interconnectedness, the Great Red Spot has neighbors that also play significant roles in Jupiter's atmospheric ballet. Nearby, there are smaller storms and vortices, some of which are absorbed by the Great Red Spot, while others drift away, their paths altered by the larger storm's gravitational pull. It's a reminder of how celestial bodies and phenomena influence each other in a cosmic dance. Here's a delightful thought. While we often think of storms as chaotic, the Great Red Spot's movements can be quite rhythmic. It rotates counterclockwise with a steady period of about 6 Earth days. This consistent rotation is part of what has allowed it to endure for so many years, a testament to the stability amidst the chaos of the Jovian atmosphere. Did you know that the Great Red Spot may even hold secrets about Jupiter's interior? The energy it releases and the patterns it creates provide clues to what's happening beneath the visible layers of clouds. By studying this storm, scientists hope to gain insights into the mysterious hidden world below Jupiter's thick cloud cover. As we explore more about the Great Red Spot, it's fascinating to realize that its shape and size are gradually changing over time. Observations suggest that it's been shrinking slowly for the past few decades. This gradual transformation offers a wealth of information about the ongoing processes within Jupiter's atmosphere, and scientists continue to watch closely to see what changes may come next. A curious aspect of the Great Red Spot is its ability to maintain such high velocities despite the seemingly calm appearance when viewed from afar. This contrast between the apparent serenity and the internal activity is a beautiful reminder of the complexity and layers of nature's designs, where what lies beneath often remains hidden from casual observation. Another intriguing feature of this mighty tempest is its temperature variations. While the upper clouds are icy cold, the depths of the storm are much warmer, creating a dramatic temperature gradient. This temperature range not only contributes to the storm's energy, but also provides researchers with a rich field of study as they seek to understand the mechanics of Jovian weather. Speaking of mechanics, let's consider the role of Jupiter's immense size and gravity in sustaining the Great Red Spot. This massive planet, with its strong gravitational force, ensures that the storm remains confined and energized within Jupiter's atmospheric layers. Without such a powerful gravitational anchor, the storm might have dissipated long ago. It's also worth noting that the Great Red Spot is a key feature that draws attention to Jupiter's uniqueness among the planets in our solar system. While other planets have storms, none are quite like the Great Red Spot in terms of scale, intensity, and historical significance. This singularity makes it a focal point for scientific inquiry and a source of endless fascination. Lastly, the Great Red Spot is not just a static feature, but a dynamic laboratory for understanding the broader dynamics of our solar system. By observing and analyzing this storm, scientists can refine their models of atmospheric processes, not only for Jupiter, but for many other celestial bodies. Each new discovery adds a piece to the puzzle of how planets and their atmospheres work, enriching our comprehension of the universe. As you drift into a peaceful slumber, let your imagination wander through the vast expanse of Jupiter's skies. Picture the swirling colors and patterns of the Great Red Spot, a cosmic masterpiece that continues to inspire wonder and curiosity. May your dreams be filled with the beauty and mysteries of the cosmos, and may you find serenity in the universal dance of the planets and stars. Imagine, if you will, the sheer age of the Great Red Spot. This monumental storm has been raging for at least 350 years. Some astronomers believe it might have been observed as early as the 17th century. Isn't it incredible to think about how this single storm has outlasted generations of human history, witnessing the ebb and flow of entire civilizations from its distant perch? The continuity of the Great Red Spot offers a fascinating glimpse into the resilience and persistence of natural phenomena over time. Here's something you might find intriguing. Despite its name, the Great Red Spot isn't always red. Its color can shift, varying from deep brick red to lighter shades of salmon or even a pale pink. These color changes are thought to result from different substances and compounds, such as sulfur and phosphorus reacting under the influence of ultraviolet light from the sun. This shifting palette makes the Great Red Spot not only a wonder of dynamics, but also of art, painting Jupiter's face with ever-changing hues. Did you know that the Great Red Spot has an incredibly deep reach into Jupiter's atmosphere? This colossal storm extends downwards for hundreds of kilometers, which is far deeper than any storm on Earth could ever penetrate. This vertical dimension adds another layer of complexity to the storm's structure and behavior, revealing more about the inner workings of Jupiter's atmosphere and the forces that sustain such a formidable feature. As we dive deeper into the mysteries of the Great Red Spot, consider how its presence influences the entire Jovian weather system. The energy from this mammoth storm helps power other atmospheric phenomena on Jupiter, contributing to the planet's dynamic climate. It's like a giant engine, continuously churning and driving the winds that sweep across Jupiter's swirling cloud tops, creating a symphony of meteorological activity. Switching gears, there's another captivating aspect to ponder: the Great Red Spot's relationship with Jupiter's magnetic field. As this storm churns, it contributes to the complexities of Jupiter's already immense magnetic field, one of the strongest in the solar system. The interplay between the magnetic field and the storm is yet another layer of interaction that scientists are keen to unravel, as it might hold clues to the internal dynamics of the giant planet. And speaking of mysteries, have you ever wondered about the future of the Great Red Spot? While it's been shrinking slowly over recent years, its ultimate fate remains uncertain. Will it eventually dissipate, or will it stabilize and endure for centuries to come? This question continues to intrigue scientists, who watch with eager anticipation to see how the storm evolves in the coming decades. Here's an interesting tidbit: the Great Red Spot is not a perfect circle, but rather an elongated oval. This peculiar shape is a result of the storm's rotation and the surrounding atmospheric currents that stretch it into its characteristic form. It's a reminder that nature rarely adheres to perfect geometries, instead crafting unique forms that are as functional as they are fascinating. Now, imagine the sounds within the Great Red Spot. While we might never hear them firsthand, scientists speculate that the storm generates intense sounds and vibrations due to its ferocious winds and chaotic movements. These acoustics, if they could be heard, would likely be unlike anything we experience on Earth, adding an auditory dimension to our understanding of this colossal tempest. And here's a delightful thought: the Great Red Spot is a window into the past. Because it's been observed for centuries, it offers a continuous record of Jupiter's atmospheric conditions over time. By studying historical observations alongside modern data, scientists can track changes in the storm and better understand the broader climatic shifts on Jupiter. It's also fascinating to consider how the Great Red Spot serves as a marker for understanding atmospheric phenomena on exoplanets. By studying this storm, scientists can develop models that help predict weather patterns on planets beyond our solar system. This cross-extrapolation enhances our ability to imagine the climates of distant worlds, expanding our cosmic horizons. Another surprising fact is that the Great Red Spot has inspired countless works of art and literature, capturing the imaginations of storytellers and artists alike. Its iconic presence in our collective consciousness serves as a muse, reminding us of the beauty and mystery that lie beyond our earthly confines. This artistic legacy underscores the storm's impact, transcending scientific boundaries and entering the realm of human creativity. Now, Let's reflect on the sheer power of the Great Red Spot. The energy contained within this storm is so immense that it's often compared to the combined output of several nuclear power plants. This staggering energy output highlights the enormity of the forces at play in Jupiter's atmosphere, a testament to the planet's raw and untamed nature. Lastly, it's worth considering how the Great Red Spot enriches our understanding of weather here on Earth. By studying such an extreme and enduring weather system, scientists gain insights that can inform our comprehension of atmospheric dynamics, helping us appreciate the delicate balance of conditions that sustain life on our own planet. As you continue to ponder the mysteries and wonders of the Great Red Spot, let your mind drift into the tranquil embrace of sleep. Imagine the swirling colors and powerful winds of Jupiter's majestic storm, a cosmic force that continues to captivate and inspire. May your dreams carry you to distant worlds and beyond, where the wonders of the universe await your exploration. Imagine for a moment the sheer scale of the Great Red Spot. If you were to place Earth beside it, you might be surprised to learn that our entire planet would fit comfortably within its boundaries. This gives you a sense of the vastness of this Jovian storm, a behemoth that dwarfs anything we've ever seen in our own skies. When you consider such immense size, it's no wonder that the storm has become one of the most studied features in our solar system. Speaking of size, the intensity of the Great Red Spot's winds is another aspect that captures the imagination. Did you know that these winds can reach speeds of up to 430 kilometers per hour? That's faster than the most powerful hurricanes recorded on Earth. Just picture the incredible force generated by those howling winds, a true testament to the storm's relentless power. Now, think about how long the Great Red Spot has been around. It's astonishing to realize that this storm has been continuously observed for over 350 years, ever since telescopes were first turned toward Jupiter in the 17th century. Its longevity provides a fascinating glimpse into the stability and resilience of such a complex atmospheric phenomenon. Here's a fascinating tidbit. The Great Red Spot is not only an atmospheric marvel, but also a thermal one. The storm is significantly warmer at its core than the surrounding areas. This temperature difference contributes to the storm's dynamics and longevity, adding yet another layer to its intricate behavior. Imagine the heat swirling within, fueling the storm's persistence through the ages. Another intriguing aspect of the Great Red Spot is its altitude. It's perched higher in Jupiter's atmosphere compared to the surrounding clouds. This elevation, combined with the storm's vibrant hues, makes it stand out even more dramatically when observed from afar. It's as if the Great Red Spot is a crown atop the swirling majesty of Jupiter's atmosphere. Reflecting on its interactions with neighboring atmospheric features, the Great Red Spot occasionally engulfs smaller storms or disturbances that drift too close. This assimilation process can alter the storm's shape and color, sustaining its energy while contributing to its ever-evolving appearance. It's a reminder of the intricate dance of Jupiter's atmospheric dynamics, where nothing remains static for long. Let me share something interesting about the observation of the Great Red Spot over the centuries. Some of the earliest records come from astronomers using primitive telescopes, whose detailed sketches and descriptions have allowed scientists today to trace the storm's evolution over time. This continuity in observation is a unique feature of the Great Red Spot, bridging centuries of human curiosity and scientific endeavor. As you ponder the scale of this colossal storm, consider that the Great Red Spot's influence extends beyond its immediate vicinity. It affects the atmospheric currents that encircle Jupiter, creating ripples that travel across the planet. These interactions make the Great Red Spot a central player in Jupiter's meteorological system, driving changes that resonate through the planet's vast atmosphere. Here's a delightful thought. Despite its tumultuous nature, the Great Red Spot is a relatively stable feature when compared to Earth's transient weather systems. Its persistence over the centuries challenges our understanding of atmospheric dynamics, prompting scientists to explore what makes this storm so enduring. Perhaps it's the unique conditions of Jupiter's atmosphere, or maybe there's a hidden mechanism that sustains its energy. The mystery continues to entice. Consider the impact of the Great Red Spot beyond the realm of science. This iconic storm has captured the imaginations of artists, authors, and dreamers alike. Its presence in literature and art reflects humanity's enduring fascination with the wonders of our universe, inspiring creativity and exploration in countless ways. The storm's swirling beauty serves not just as a scientific marvel, but as a source of inspiration across cultures and generations. It's also intriguing to contemplate how the Great Red Spot aids our understanding of distant worlds. By studying this enduring storm, scientists develop models that help predict atmospheric behavior on exoplanets. This cross-planetary extrapolation expands our knowledge of the cosmos, offering glimpses into the climates of planets light years away. The Great Red Spot thus becomes a key to unlocking the mysteries of the universe, guiding us on our quest to learn about worlds beyond our own. And speaking of influence, the Great Red Spot also plays a role in shaping Jupiter's rings. As particles are ejected from the storm, they occasionally become part of the planet's faint ring system, contributing to its formation and maintenance. The interplay between the storm and the rings adds yet another dimension to the interconnectedness of Jupiter's many features. Lastly, think about the Great Red Spot's role as a natural laboratory. It provides scientists with a chance to study extreme atmospheric conditions, offering insights that can be applied to other planetary bodies, including our own Earth. By examining this enduring storm, we gain a deeper understanding of the forces that shape weather and climate, enhancing our appreciation for the complex systems that govern planetary atmospheres. In this way, the Great Red Spot not only enriches our knowledge of Jupiter, but also informs our understanding of planetary science as a whole. As you relax into the night, let these thoughts of the Great Red Spot's wonders and mysteries lull you into a peaceful slumber. Imagine if you could travel to Jupiter and witness the Great Red Spot firsthand. This colossal storm is so immense that it could easily swallow the entire Earth. In fact, 2 or even 3 Earth-sized planets could fit comfortably within its boundaries. That's a staggering thought, isn't it? Such sheer scale is difficult to comprehend, yet it adds to the awe-inspiring grandeur of this celestial phenomenon. Did you know that the Great Red Spot isn't actually red all the time? Its color can range from a deep reddish-brown to a paler, almost salmon hue. Scientists theorize that the variations in color might be due to changes in the chemical composition of the atmosphere, or perhaps the interaction of sunlight with the storm's upper layers. It's as if Jupiter's atmosphere is painting this ever-changing masterpiece for us to admire from millions of kilometers away. Here's a curious fact. The Great Red Spot has been shrinking over the last century. In the late 1800s, the storm was estimated to be about 40,000 kilometers in diameter. Today, it's less than half that size. Despite this reduction, the storm remains a dominant feature of Jupiter's atmosphere, a true testament to its resilience and power. Scientists continue to study these changes to understand the processes behind its gradual transformation. Speaking of long-term changes, Did you know that the Great Red Spot was once thought to be a solid body? Early astronomers believed it might be a continent-like structure or a gigantic mountain floating in Jupiter's atmosphere. It wasn't until much later, with advances in our understanding of gas giants, that we realized it's actually a massive storm. This evolution in thought highlights the journey of scientific discovery and how our perceptions of the universe continue to unfold. Let's ponder the storm's depth for a moment. The Great Red Spot extends deep into Jupiter's atmosphere, reaching depths of around 450 kilometers. This vertical reach plays a crucial role in the storm's dynamics, allowing it to draw energy from different atmospheric layers. It's as if the storm is tapping into a vast reservoir of power, sustaining itself through the ages. The enormity of this vertical column is truly mind-boggling. Have you ever wondered about the forces that keep the Great Red Spot rotating? The storm is powered by a complex interplay of atmospheric currents that swirl around Jupiter. These currents create a vortex effect, much like a spinning top, helping maintain the storm's rotation. This dynamic system ensures that the Great Red Spot continues its endless dance across Jupiter's face, a mesmerizing whirl that captivates all who gaze upon it. Now, let me share something truly fascinating about the storm's winds. They're not just powerful, they're also incredibly organized. Within the Great Red Spot, the winds form a series of concentric circles, each moving at different speeds. This layered structure is thought to contribute to the storm's stability, preventing it from dissipating over time. Imagine the precision of these winds, each layer moving in harmony with the next, an intricate ballet performed by nature itself. Here's an intriguing tidbit. The Great Red Spot's atmosphere is rich in complex molecules. Scientists have detected traces of organic compounds like hydrogen cyanide and acetylene within the storm. These molecules are formed through chemical reactions driven by the planet's extreme conditions. The presence of such compounds offers a glimpse into the fascinating chemistry that occurs in Jupiter's atmosphere, a natural laboratory where the building blocks of life might be assembled. Speaking of chemistry, did you know that the Great Red Spot emits a faint glow? This glow is the result of auroras, similar to the northern and southern lights on Earth, caused by charged particles interacting with the planet's magnetic field. The auroras add a mystical touch to the storm, a gentle reminder of the wonders lying hidden beneath its churning clouds. Picture this glow illuminating the storm from within, a soft light enveloping the turbulent surroundings. Here's a thought-provoking aspect of the Great Red Spot. Its influence extends beyond Jupiter itself. The storm's powerful winds and dynamic nature create waves in the planet's atmosphere that can affect the orbits of Jupiter's moons. These moons, locked in a gravitational dance with their giant host, respond to the subtle nudges from the Great Red Spot, their movements intertwined with the storm's rhythmic pulse. Consider the role of the Great Red Spot in shaping our understanding of planetary weather systems. By studying this storm, scientists have developed models that offer insights into atmospheric processes on gas giants. These models have broadened our knowledge not just of Jupiter, but of other similar planets in our solar system and beyond. It's as if the Great Red Spot is a window into the atmospheric wonders that await us in the far reaches of space. Reflecting on its enduring presence, it's fascinating to think about the Great Red Spot as a guardian of Jupiter's secrets. With each passing year, it continues to intrigue and challenge our understanding, inviting us to explore deeper into the mysteries of the universe. Its persistence serves as a reminder of the vast and complex nature of the cosmos, a realm where wonders abound and discoveries await those who seek them. Now, Let the gentle curiosity of these facts about the great red spot cradle you into a tranquil state, allowing the mind to wander through the stars. Inspired by the mysteries of the universe, may it be a serene and dream-filled journey as you drift into restful sleep. Imagine if you could hear the great red spot. Although space is silent to our ears, the storm's immense energy generates sound waves within Jupiter's atmosphere. These waves travel across the planet, creating a symphony of vibrations that, if we could perceive them, might offer an eerie yet captivating soundtrack to this colossal storm. Isn't it fascinating to think of a storm not just as something we see, but something that could be heard? Speaking of sounds, did you know that the Great Red Spot is also a heat source? The storm creates heat that warms Jupiter's upper atmosphere, making it significantly hotter than it should be at those altitudes. This heating effect is still something of a mystery, but it's thought that the turbulent motions and high winds within the storm could be generating energy that radiates outwards. This is a reminder of how dynamic and influential the Great Red Spot truly is. Here's a curious detail. The colors of the Great Red Spot are not static. Over time, its hues have shifted, with the spot appearing more orange or more red at different periods. Researchers believe these changes might be linked to chemical reactions, driven by variations in sunlight and cosmic radiation that reach Jupiter. It's as if the storm is a living canvas, constantly being repainted by the forces of nature. Have you ever wondered about the Great Red Spot's impact on the rest of Jupiter's atmosphere? The storm influences weather patterns across the planet. Its powerful winds can steer atmospheric currents and create weather systems on a planetary scale. This immense influence is akin to how Earth's oceans drive our climate, showcasing the interconnectedness of Jupiter's atmospheric phenomena. Interestingly, the Great Red Spot might have companions. Observations have occasionally spotted smaller storms forming around and merging into the Great Red Spot. These smaller vortices can either be absorbed by the larger storm or spin off and dissipate over time. The storm acts like a giant atmospheric blender, mixing and mingling with other weather systems in a cosmic dance. Let's consider the size of Jupiter's Great Red Spot once more. Even though it's been shrinking, it remains large enough to fit 1 or 2 Earths across its diameter. This immense scale is difficult to comprehend fully, and it's a testament to the vastness of Jupiter itself. The storm's size ensures it remains a dominant feature in any image of the planet, a swirling, colorful eye in the midst of swirling clouds. Here's a delightful fact. The Great Red Spot has been a part of human curiosity for centuries. It was first observed by astronomers as far back as the 17th century, making it one of the longest studied weather phenomena in our solar system. This long history of observation has enabled us to track its changes and deepen our understanding of both Jupiter and atmospheric science. Speaking of history, there's a peculiar hypothesis that suggests the Great Red Spot might have once been 2 storms that collided and merged. This idea stems from the storm's complex structure and the way it has maintained its form over the years. While this hypothesis remains speculative, it offers a tantalizing possibility of how such a massive storm could have formed and evolved. Did you know that the Great Red Spot's longevity puzzles scientists? Most storms on Earth last for days or weeks, yet this Jovian tempest has persisted for centuries. The storm's ability to sustain itself for so long is thought to be due to Jupiter's lack of a solid surface, which allows the storm to draw energy continuously from the planet's vast atmosphere without losing momentum. Here's a surprising aspect. The Great Red Spot experiences turbulence on a scale that dwarfs anything on Earth. The storm's winds can reach speeds of up to 430 kilometers per hour, more than twice the speed of the strongest hurricanes on our planet. This turbulence is a key factor in the storm's endurance, as it helps maintain the energy balance within this towering vortex. Imagine the complexity of the Great Red Spot's internal structure. It's believed that the storm's core is somewhat shielded from the harshest atmospheric conditions by its outer layers. This protective feature may help the storm maintain its stability and prevent its rapid dissipation. Think of it as an onion with multiple layers, each playing a role in the storm's intricate machinery. The Great Red Spot is not just a subject of human fascination, it's an inspiration for space missions. NASA's Juno spacecraft, which arrived at Jupiter in 2016, has provided us with unprecedented views of the planet, including detailed images of the Great Red Spot. These close-up observations reveal the storm's intricacies, offering scientists valuable data to unravel its mysteries further. And here's something truly remarkable. The Great Red Spot might hold clues to the secrets of the solar system's formation. By studying its composition and behavior, scientists hope to gain insights into the early conditions of our solar neighborhood. The storm acts like a time capsule, preserving information from billions of years ago when the planetary systems were taking shape. Reflect on the idea that the Great Red Spot serves as a metaphor for endurance and change. Despite its age and shifting form, it remains a steadfast feature in the cosmic landscape. Its constant presence through centuries of human observation connects us to the past, while its dynamic nature reminds us of the ever-evolving wonders of the universe. As you ponder these celestial mysteries, let them guide you toward a peaceful rest, where dreams are filled with the marvels of the cosmos, carried along by the gentle rhythm of the Great Red Spot's eternal rotation. Have you ever marveled at the fact that the Great Red Spot is so large, it actually modifies the planet's gravity field? This colossal storm is such a significant feature that it causes slight variations in Jupiter's gravitational pull, which have been detected by spacecraft. These variations offer scientists clues about the storm's mass and the hidden dynamics beneath its swirling clouds. Speaking of surprises, did you know the Great Red Spot emits more heat than the surrounding atmosphere? This phenomenon, known as a hot spot, suggests that the storm isn't just a passive part of Jupiter's atmosphere, but an active participant in the planet's thermal dynamics. The excess heat could be a result of turbulent mixing and internal processes that remain a puzzle to scientists. Imagine this. The Great Red Spot is so massive and enduring that it may even affect Jupiter's magnetic field. This supposition arises from the storm's deep roots, potentially reaching down into the planet's interior where its magnetic field is generated. Such interactions could provide valuable insights into the mysteries of magnetic fields in giant planets. Here's a curious fact. The Great Red Spot might be responsible for some of Jupiter's most spectacular auroras. Though primarily driven by the planet's magnetic interactions with its moons, the storm's influence on atmospheric currents might enhance these beautiful displays of light, adding another layer to Jupiter's cosmic allure. Another intriguing aspect of the Great Red Spot is its mysterious color palette. While its iconic red hue is famous, researchers are still investigating the exact chemicals responsible for this striking coloration. Compounds like phosphorus or sulfur are potential contributors, but the full recipe remains an enigma, as elusive as the storm itself. Have you ever considered that the Great Red Spot could contain elements that are rare or even non-existent on Earth? The extreme conditions within the storm, high pressures and temperatures, might allow for unique chemical compounds to form. These exotic materials could unlock new scientific understanding of planetary chemistry. Interestingly, the Great Red Spot's shape is not a perfect circle. Instead, it often takes on an elliptical form, with its dimensions fluctuating over time. These changes in shape could be linked to the storm's interactions with other atmospheric phenomena, highlighting the dynamic and ever-changing nature of this Jovian giant. And here's a delightful little-known tidbit. The Great Red Spot has its own rhythm. Observations have revealed oscillations within the storm, like a natural heartbeat pulsing at regular intervals. These rhythmic patterns might be related to internal waves or energy transfers, offering another layer of complexity to this extraordinary storm. Imagine for a moment that the Great Red Spot might be a source of music. Scientists have converted the storm's electromagnetic waves and oscillations into sound, creating a unique symphony based on its atmospheric dynamics. This auditory representation provides a new way to experience the storm's majesty, turning data into art. Another intriguing notion is that the Great Red Spot could be influencing the distribution of ammonia in Jupiter's atmosphere. Ammonia is a key component of the planet's cloud formation, and the storm's powerful currents might be redistributing this gas, contributing to the diverse and ever-changing patterns observed on the planet. Here's something that might surprise you. The Great Red Spot has its own weather patterns. Within the storm, smaller vortices, jets, and eddies form, creating a complex and layered structure. This internal weather system operates on its own terms, a testament to the chaos and order intertwined within the storm's swirling embrace. Speaking of which, did you know that the Great Red Spot might hold secrets about the atmospheric conditions of other gas giants? By studying this Jovian storm, scientists can draw parallels with similar features on planets like Saturn, Uranus, and Neptune, broadening our understanding of atmospheric dynamics across the solar system. Remarkably, the Great Red Spot is not just a passive observer of its environment, it's an active player in shaping Jupiter's cloud bands. The storm's immense energy and motion influence the surrounding atmosphere, contributing to the formation and movement of the planet's iconic stripes. Here's a particularly fascinating idea. The Great Red Spot might be a window into Jupiter's hidden oceans. Some theories propose that the storm's roots extend deep into the planet, possibly interacting with subsurface oceanic layers. These interactions could drive the storm's energy and longevity, offering a tantalizing glimpse into the unseen depths of Jupiter. Finally, consider this. The Great Red Spot's persistence and power may be fueled by processes that are not fully understood yet. While it's known that Jupiter's rapid rotation and deep atmosphere contribute to the storm's endurance, there could be unknown mechanisms at play, sustaining this immense vortex through the ages. As we journey through the mysteries of Jupiter's Great Red Spot, let these surprising facts guide your thoughts toward a gentle reflection on the wonders of the universe. Each detail adds to the rich tapestry of knowledge, inviting you to dream of the distant reaches of space where storms like the Great Red Spot continue to swirl in majestic, timeless dances. Let me share something intriguing with you. The Great Red Spot, in its fascinating complexity, is not just a single storm, but rather a layer cake of swirling turbulence. Imagine each layer behaving differently, influenced by varying atmospheric pressures and temperatures. This layered structure allows the storm to sustain itself by drawing energy from its surroundings. Speaking of energy, did you know that the winds within the Great Red Spot are among the fastest in the solar system? These winds can reach speeds of up to 400 kilometers per hour, faster than the most ferocious hurricanes on Earth. It's a mind-boggling thought, isn't it? This ferocity contributes to the storm's awe-inspiring stability and longevity. Here's a curious idea. The Great Red Spot might serve as a gigantic planetary blender. The forces within this storm mix gases and materials, potentially bringing secrets from Jupiter's depths up to the more visible cloud layers. This mixing could be essential for understanding the chemical and physical processes at work in the gas giant's atmosphere. Can you imagine a storm so vast that it creates its own gravitational waves? The Great Red Spot is so massive and dynamic that it might generate ripples in the fabric of space-time itself. While these waves are minuscule compared to those caused by more cataclysmic events, their existence adds another layer of intrigue to this celestial phenomenon. Here's something fascinating. The storm's color isn't static. Over the years, the Great Red Spot has changed hues, shifting from deep crimson to pale salmon. These variations might be tied to chemical processes in the atmosphere or changes in the storm's intensity. Observing these shifts helps scientists better understand the storm's behavior and evolution. Interestingly, the Great Red Spot's longevity might be attributed to its isolation. Despite its size, the storm is well separated from other large atmospheric features, allowing it to maintain its form without significant interference. This isolation means the storm can persist without being disrupted by Jupiter's other powerful atmospheric currents. Now, here's a thought-provoking notion. The Great Red Spot may act as a colossal energy reservoir. By capturing and storing kinetic energy, the storm could essentially fuel its own continuation. This self-sustaining mechanism would explain why it has persisted for centuries, defying the chaotic tendencies of Jupiter's atmosphere. Did you know that the Great Red Spot might be influencing weather patterns not just on Jupiter, but potentially affecting the environment of its moons as well? The storm's powerful energy and extensive reach could have ripple effects, altering the weather systems or even geological activity on the moons closest to this Jovian giant. Here's a delightful little fact. The Great Red Spot has been the subject of artistic inspiration throughout history. From ancient sketches by early astronomers to modern digital renderings, the storm has captured imaginations and fueled creativity across cultures and eras. It's a testament to the enduring allure of this planetary marvel. And here's something that might surprise you. The Great Red Spot could serve as a natural laboratory for testing theories about atmospheric dynamics. By studying this storm, scientists can simulate conditions and test ideas that might be applicable to exoplanets or other celestial bodies, expanding our understanding of the universe beyond the confines of our solar system. Imagine a storm so large that it could accommodate 2 or 3 Earths within its boundaries. The sheer scale of the Great Red Spot is astonishing, offering a humbling perspective on the vastness of Jupiter compared to our home planet. This colossal size is a reminder of the majesty and mystery that the cosmos holds. Here's an interesting tidbit. The Great Red Spot is not alone. It's accompanied by smaller, less conspicuous storms that circle around it. These companion storms might interact with the Great Red Spot, influencing its shape and behavior. Such interactions add to the dynamic and constantly evolving nature of Jupiter's atmosphere. Did you ever consider that the Great Red Spot could be a relic from Jupiter's past? Some researchers speculate that this storm might have formed during a different climatic era of the planet, preserving conditions from a time long before our current understanding of Jupiter's atmospheric dynamics. And speaking of history, the Great Red Spot is often seen as a cosmic time capsule. Its enduring presence offers clues about how Jupiter has evolved over millions of years. By studying its properties and changes, scientists can piece together a timeline of events that have shaped the planet. Finally, picture this: the Great Red Spot as a guardian of secrets, holding within its swirling depths a wealth of untapped information about the universe. Each stormy gust and whirling eddy is a chapter in the story of Jupiter, a narrative waiting to be deciphered by those who dare to dream of exploring the unknown reaches of our solar system. As we continue our gentle exploration of Jupiter's Great Red Spot, let these surprising and delightful facts guide your thoughts into a peaceful reverie, pondering the wonders of space and the endless possibilities that lie beyond our sky. Imagine the immense power that a storm like the Great Red Spot must wield. It's fascinating to think that despite its turbulent nature, this immense vortex has a rhythm of its own. Did you know that the Great Red Spot rotates counterclockwise? This anticyclonic movement is typical for storms in the planet's southern hemisphere. The rotation is so stable that it's been possible for astronomers to track its changes over the centuries, painting a picture of its consistent yet ever-evolving nature. Now, here's a captivating detail. The Great Red Spot is shrinking. Observations over the past few decades show a gradual reduction in its size. Once, it was large enough to fit almost 3 Earths side by side, but now, only 1 Earth could comfortably nestle within its boundaries. Scientists are still trying to understand why this contraction is happening, pondering if it marks the beginning of the storm's end or just another phase in its long life. Speaking of its dimensions, the Great Red Spot isn't perfectly circular. It's more of an oval shape, stretching wider than it is tall. This elongation might influence the way the storm interacts with surrounding atmospheric currents, potentially altering its behavior and lifespan. Here's a thought-provoking notion. The color of the Great Red Spot is a mystery that continues to baffle scientists. While it is famous for its reddish hue, the exact reasons for this coloration remain unclear. Some suggest it's due to the presence of compounds like phosphorus or sulfur in the upper atmosphere. Others propose that the sun's ultraviolet radiation might chemically alter certain elements in Jupiter's clouds, producing those iconic reddish tones. Did you ever wonder how a storm this vast gets its energy? Interestingly, the Great Red Spot might tap into Jupiter's internal heat. Unlike Earth, where weather is driven primarily by solar energy, Jupiter's atmosphere benefits from the heat that escapes from its core. This internal warmth might fuel the storm, sustaining it over the centuries. While pondering the depths of this majestic storm, consider this. Beneath the vibrant and chaotic cloud tops, the Great Red Spot might extend deep into Jupiter's atmosphere. Some models suggest that its roots could reach thousands of kilometers below the visible clouds, intertwining with hidden layers that tell tales of the planet's interior dynamics. Here's an intriguing thought. The Great Red Spot might be older than any storm on Earth. Historical records indicate its presence for at least 350 years, yet it could be much older, predating modern observations by centuries. This ancient storm offers a window into a part of Jupiter's history that remains elusive yet endlessly fascinating. Switching topics slightly, have you ever considered the impact of lightning within such a massive storm? The Great Red Spot could host colossal lightning strikes, far more powerful than those we experience on Earth. These electrical discharges might interact with the surrounding gases, altering the chemistry of the storm and contributing to its vivid color palette. One might imagine that a storm of this magnitude must have a profound effect on Jupiter's global weather patterns. Indeed, the Great Red Spot acts like a dynamic barrier, influencing atmospheric flows both above and below its hefty swirl. The ripples of its presence can be felt across the entire Jovian atmosphere, demonstrating the interconnectedness of planetary weather systems. And here's a concept that might surprise you. The Great Red Spot's existence is a delicate balance. If conditions on Jupiter were only slightly different, the storm might not persist. This precarious equilibrium highlights the intricate dance of forces at play, where gravitational, thermal, and chemical elements merge to craft this enduring masterpiece in the sky. Have you ever thought about the Great Red Spot as a source of sound? While space is a vacuum and lacks an atmosphere to carry sound waves as we know them, the storm generates powerful acoustic waves within Jupiter's thick gaseous envelope. These waves might create sonic phenomena that, if we could hear them, would be unlike anything on Earth. Imagine the Great Red Spot as a sculptor shaping its environment in unseen ways. This colossal storm could be carving intricate patterns into the cloud layers of Jupiter, leaving a legacy of textures and forms unseen by human eyes, but perhaps recorded in the windswept tapestry of the planet's ever-shifting surface. Here's a delightful possibility. By studying the Great Red Spot, we might learn more about Earth's ancient storms. This Jovian tempest provides a natural laboratory for understanding how enormous weather systems evolve, offering insights that could apply to our planet's past climate and weather phenomena. It is remarkable to note how the Great Red Spot's scale and power continue to captivate our imaginations. As we delve into these myriad mysteries, we uncover new layers of complexity and wonder within this cosmic storm. Each revelation is a piece of the puzzle, urging us to further contemplate the extraordinary nature of Jupiter and the universe beyond. With every discovery, we draw closer to unveiling the secrets that the Great Red Spot, like a patient guardian, holds within its swirling embrace. Imagine diving deep into the heart of the Great Red Spot and uncovering secrets that defy our earthly experiences. Did you know that this mesmerizing storm rotates counterclockwise? It's known as an anticyclonic storm, which is quite different from the cyclones we're familiar with on Earth. This means that the center of the storm is an area of high pressure rather than low pressure, creating a unique atmospheric dynamic. Here's another intriguing detail. The wind speeds within the Great Red Spot are staggering. They can reach up to 430 kilometers per hour, faster than the fiercest hurricanes on Earth. These winds whip around in a relentless dance, possibly sustained by Jupiter's intense rotation and internal heat, adding to the storm's longevity. But what about the storm's temperature? Surprisingly, the Great Red Spot is colder than its surroundings. The upper clouds are much cooler, a common feature in large storms on Jupiter. This temperature difference could influence the storm's dynamics and its interaction with the rest of the planet's atmosphere. Speaking of the cloud tops, they are higher than the clouds surrounding them. This elevation might result from the immense energy and upward currents within the storm. Imagine the cloud layers billowing upwards, as if trying to reach for something beyond the Jovian sky. Did you ever wonder how the Great Red Spot maintains its position? It doesn't drift across Jupiter like storms on Earth do across our planet. Rather, it appears to be anchored by Jupiter's powerful jet streams, which act like invisible tracks, guiding and containing the storm's swirling mass. Let's turn our gaze to the impact of the Great Red Spot on Jupiter's atmosphere. The storm's massive size and energy can generate waves that travel across the planet. These atmospheric waves might help transport heat and energy, influencing Jupiter's climate on a global scale. You might be surprised to learn that the Great Red Spot isn't always the same color. Its hue can vary, ranging from deep brick red to pale orange. These changes might result from chemical reactions in the atmosphere, perhaps influenced by sunlight or interactions with other gases. And here's an unexpected twist. The chemicals within the Great Red Spot might be similar to those found in Earth's volcanic plumes. Scientists speculate that compounds like ammonia and water rise from the depths of Jupiter, mixing with the storm and altering its chemical composition. This similarity offers a fascinating parallel between the alien world of Jupiter and our own planet. Picture this: the Great Red Spot could be influencing Jupiter's magnetosphere, the region dominated by the planet's magnetic field. The storm's intense activity might generate electric currents that interact with this field, possibly contributing to the planet's radiant auroras seen at its poles. Have you considered the idea that the Great Red Spot might have counterparts elsewhere in the universe? Other gas giants, like Saturn and Neptune, also exhibit large storms. Studying these storms across different planets helps scientists understand the fundamental forces shaping atmospheres throughout our galaxy. Here's a fascinating thought. The Great Red Spot might be affecting Jupiter's moons. The gravitational pull and atmospheric waves generated by the storm could interact with the orbits and surfaces of these moons, creating subtle but significant changes over time. Can you imagine the Great Red Spot as a beacon of sorts? Its presence has guided astronomers for centuries, helping us understand not only Jupiter, but also the broader cosmos. Its constant evolution serves as a reminder of the dynamic and ever-changing nature of our universe. And finally, let's ponder the role of technology in unraveling the mysteries of the Great Red Spot. Advanced spacecraft like the Juno probe provide us with detailed images and data, allowing scientists to study the storm in unprecedented detail. These technological marvels continue to expand our understanding, revealing new facets of this enigmatic feature with each passing day. Each of these surprising facts adds another layer to the captivating story of Jupiter's Great Red Spot. As we explore these wonders, we're reminded of the incredible complexity and beauty that exist beyond our earthly experiences, inviting us to dream and discover the mysteries that lie within our solar system and beyond. Have you ever wondered why the Great Red Spot has persisted for so many centuries? The longevity of this colossal storm is nothing short of a celestial marvel. Some scientists believe that the absence of solid land on Jupiter allows the storm to maintain its strength, as there's no landmass to disrupt its flow. This is quite different from Earth, where storms dissipate upon encountering continents. Without such interruptions, the Great Red Spot can continue its eternal dance across Jupiter's gaseous surface. Isn't it fascinating how the dynamics of a planet can influence the lifespan of a storm? Let's consider another intriguing aspect: the storm's sheer size. The Great Red Spot is so large that it could engulf Earth 2 to 3 times over. This gargantuan scale has reduced over time, but even in its shrunken state, the storm remains an immense force to be reckoned with. Imagine a storm so vast that it reshapes our concept of scale and power. The reduction in size is yet another mystery, hinting at the complex processes at work within Jupiter's atmosphere. Speaking of mysteries, the Great Red Spot's depth is another subject of fascination. Probing into the depths of this storm reveals that it could extend between 300 to 500 kilometers deep into Jupiter's thick atmosphere. This incredible depth suggests that the storm reaches well below the cloud tops, into regions where pressures are much higher. It makes you wonder, what unseen forces lie beneath these swirling layers that maintain such a formidable vortex? Here's something else to ponder. The Great Red Spot emits heat. This heat emission might be linked to the storm's immense energy and the friction generated by its powerful winds. Interestingly, this exhalation of warmth could play a role in the storm's survival, creating a thermal feedback loop that sustains its energy. Can you picture a storm so intense that it breathes heat into the cosmos? Let's drift into the realm of chemistry, where the Great Red Spot offers even more surprises. The distinct red hue of the storm has long puzzled scientists. It's thought that the color results from the interaction of ultraviolet light with chemicals like ammonium hydrosulfide in the upper atmosphere. This chemical reaction might produce complex compounds, giving the storm its trademark red coloration. It's as if the storm paints itself anew, a cosmic canvas constantly reimagined by the forces of nature. Now, let me share something curious. The Great Red Spot influences the atmosphere not just locally, but globally. The storm's sheer size and energetic presence create ripples that propagate through Jupiter's atmosphere, affecting weather patterns even thousands of kilometers away. These atmospheric waves can interact with other jet streams and storms, showcasing the interconnectedness of the planet's climate system. It's a reminder of how one element, however singular, can influence an entire world. Have you considered the role of the Sun in this grand spectacle? The sunlight that reaches Jupiter is a mere fraction of what Earth receives, yet it plays a pivotal role in shaping the Great Red Spot. The Sun's rays contribute to the chemical reactions that color the storm and might even influence its dynamics. Despite being so far from our star, the Great Red Spot remains a testament to the Sun's far-reaching influence in our solar system. Reflecting on the storm's history, did you know that the Great Red Spot was first observed over 350 years ago? Since then, it has been a subject of continuous study and awe. Its persistence through the centuries has provided invaluable data, helping scientists track changes in Jupiter's atmosphere and understand how long-lasting storms behave. The storm is like a window into the past and future of our planetary neighbors. Here's another thought to ponder. The Great Red Spot's winds have not only an effect on the storm itself, but also influence the surrounding atmosphere. The powerful winds can induce turbulence in the adjacent regions, creating smaller vortices that dance around the storm's periphery. These smaller storms can merge with or be absorbed by the Great Red Spot, showcasing a dynamic and ever-evolving atmospheric ballet. As we explore further, consider the idea that the Great Red Spot acts as a boundary marker on Jupiter. The storm sits just south of Jupiter's equator, and its presence helps define the atmospheric bands that encircle the planet. These bands, with their distinct colors and characteristics, offer a glimpse into the planet's complex meteorological tapestry. It's as if the Great Red Spot serves as a silent guide, highlighting the intricate patterns woven into Jupiter's atmosphere. Lastly, let your imagination wander to the notion of the Great Red Spot as a symbol of cosmic endurance. In a universe where change is constant, this storm has stood the test of time. It serves as a reminder of the resilience and tenacity of natural phenomena, enduring through centuries as we continue our quest to understand the cosmos. Each new discovery, each revelation about its nature, adds another thread to the rich tapestry of knowledge woven around this majestic giant. So as we drift through these celestial facts, let the mysteries of the Great Red Spot lull you into a state of wonder. With every whispered secret and every unveiled truth, the storm beckons us to dream of the universe's boundless possibilities. To deepen our journey into the Great Red Spot, let's explore the intriguing relationship between the storm and Jupiter's magnetic field. It turns out that the storm's vast and powerful winds can interact with the planet's magnetic field, creating electric currents that might extend into the planet's deeper layers. This interplay between atmospheric dynamics and magnetic forces adds an electrifying dimension to our understanding of the storm's complexity. Imagine the storm as not just a meteorological phenomenon, but an electromagnetic one too. Speaking of electrical wonders, did you know that lightning strikes within the storm have been detected? These lightning bolts are not unlike those on Earth, though they occur in an environment far more extreme. Such strikes indicate the presence of water clouds beneath the uppermost layers of the storm, suggesting a dynamic and energetic atmosphere where electricity dances amidst the chaos. Here's a curious thought. The Great Red Spot might act as a kind of protective shield for some of Jupiter's smaller storms. Due to its immense size and swirling power, it can absorb or deflect these smaller systems, preventing them from growing too large or threatening its dominance. This protective role is a fascinating example of how a single entity can influence the larger meteorological landscape. In a surprising twist, the Great Red Spot might also have a role in regulating Jupiter's temperature. The storm's motion and the heat it generates could help distribute thermal energy across the planet, balancing temperature disparities that arise from its rapid rotation and varying atmospheric conditions. This thermal regulation reminds us of the interconnectedness of natural systems, where one storm can help maintain equilibrium on a planetary scale. Another thought-provoking aspect is the storm's persistence, which scientists attribute to Jupiter's lack of a solid surface. On Earth, storms eventually dissipate when they encounter land, but on Jupiter, the absence of land allows the Great Red Spot to continue swirling unabated, drawing energy from the planet's atmosphere. This perpetual motion highlights the differences in planetary environments and their impact on atmospheric phenomena. Reflecting on the storm's color, did you know that it is a relatively recent development in its long history? Early observations suggest that the Great Red Spot wasn't always red. Historical sketches indicate it may have once been more of a pale pink or even white. This color evolution hints at changing atmospheric conditions and chemical processes over the centuries, painting a dynamic portrait of the storm's history. Let me share another fascinating insight. The Great Red Spot's rotation rate is astonishingly fast. The storm completes a full rotation approximately every 6 Earth days. This rapid spin contributes to its longevity, as the centrifugal forces help maintain its structure against the forces trying to break it apart. The storm's spin is like a cosmic ballet, where balance and motion create a symphony of swirling clouds. Have you ever considered the Great Red Spot's symmetry? Observations reveal that the storm is surprisingly symmetrical, maintaining a consistent oval shape despite the chaotic forces at play. This symmetry is a testament to the storm's stability and resilience, presenting a paradoxical harmony within its turbulent confines. Interestingly, the storm's altitude plays a crucial role in its behavior. The Great Red Spot is elevated above the surrounding clouds, which might enhance its ability to draw in surrounding gases and sustain its immense energy. This altitude advantage allows the storm to remain a dominant and enduring feature on Jupiter's atmospheric stage. Here's something to ponder. The Great Red Spot might be older than we think. While we have documented observations dating back over 350 years, some scientists speculate that the storm could have been active for much longer. The possibility of such longevity speaks to the enduring nature of this colossal storm, whispering stories of a time long before our modern observations. Speaking of endurance, the storm's persistence has led to it being a natural laboratory for studying atmospheric physics. By observing the Great Red Spot, scientists gain insights into the mechanics of long-lived vortices, which can be applied to understanding other planetary atmospheres and even weather systems on Earth. It serves as a cosmic classroom, teaching us about the interplay of forces that sustain such enormous phenomena. Did you know that the Great Red Spot's winds are among the fastest in the solar system? They can reach speeds upwards of 430 kilometers per hour. These fierce gales are driven by the storm's immense energy and the planet's rapid rotation, creating a high-speed carousel of swirling gases that is both mesmerizing and intimidating. Lastly, consider the influence of the Great Red Spot on the study of exoplanets. Observing this storm helps scientists develop techniques to detect and analyze atmospheric features on distant worlds. The lessons learned from Jupiter's iconic storm enhance our search for similar phenomena in other solar systems, expanding our quest to understand planets beyond our own. As we glide through these revelations about the Great Red Spot, let each fact fill you with a sense of awe and wonder. This storm, a giant among giants, continues to captivate and inspire, inviting us to peer deeper into the cosmos. Each whisper of knowledge brings us closer to understanding the universe's grand design, painting a picture of beauty and complexity that stretches beyond our wildest dreams. Let me share a surprising detail about the Great Red Spot. Despite its massive size, it's slowly shrinking. Observations over the past century have shown a gradual decrease in its diameter. Once spanning over 40,000 kilometers, it now measures just over 16,000 kilometers across. This change in size raises intriguing questions about the storm's future and how it might continue to evolve in the coming centuries. Another curiosity lies in the Great Red Spot's mysterious coloration. Scientists are still unsure about the precise chemical processes that give the storm its striking red hue. Some theories suggest that the color might result from complex organic molecules formed by the interaction of ultraviolet radiation from the sun with chemicals like ammonia and acetylene in Jupiter's upper atmosphere. This chemical cocktail creates a canvas of colors that change as conditions above Jupiter shift. Speaking of colors, did you know that the storm's red hues are not uniform? Within the Great Red Spot, there are subtle variations in color intensity, suggesting complex interactions among the various chemicals. These variations in shade and tone add another layer of complexity to the storm's already mesmerizing appearance, making it a dynamic and ever-changing spectacle. Let's consider the storm's immense energy. The Great Red Spot generates an extraordinary amount of heat, which can actually be detected from space. This heat is thought to contribute to the storm's power and longevity, helping it to resist dissipation. The storm acts like a massive heat engine, converting kinetic energy into heat and thus sustaining itself through an extraordinary cycle of energy exchange. As we ponder its energy, it's interesting to note that the Great Red Spot's vertical structure is quite remarkable. It extends deep into Jupiter's atmosphere, much deeper than previously thought, reaching depths of up to 300 kilometers. This substantial vertical reach gives the storm access to a wide range of atmospheric layers, contributing to its complex dynamics and long-lasting nature. Here's a thought-provoking fact. The Great Red Spot's position on Jupiter has remained relatively stable. It resides in the planet's southern hemisphere, nestled between two of Jupiter's jet streams. This precise positioning allows the storm to maintain its iconic oval shape, stabilized by the surrounding atmospheric currents. The jet streams effectively act as boundaries, keeping the storm in check and preserving its grandeur. On the topic of stability, did you know that the Great Red Spot has companions? There are other, smaller atmospheric features on Jupiter that share some characteristics with the Great Red Spot, including similar colors and rotational patterns. These smaller storms can sometimes merge with the Great Red Spot or pass it by, adding to the dynamic interplay of Jupiter's atmospheric systems. Another intriguing aspect of the Great Red Spot is its potential influence on Jupiter's magnetic field. The storm's intense energy and motion could contribute to the planet's overall magnetic activity, affecting how charged particles are trapped and accelerated in Jupiter's magnetic environment. This interplay between atmospheric and magnetic forces on Jupiter is a subject of ongoing study, offering insights into the planet's complex internal processes. Let us delve into the storm's historical significance. The Great Red Spot has been observed continuously since the late 1700s, making it one of the oldest known atmospheric phenomena in the solar system. Its persistent presence has made it a valuable reference point for astronomers over the centuries, providing a stable feature against which to measure changes in Jupiter's atmosphere. And did you ever wonder how we monitor such distant storms? Modern technology allows scientists to study the Great Red Spot in unprecedented detail. Spacecraft, like the Hubble Space Telescope and the Juno mission, have provided stunning images and data, enabling researchers to track changes in the storm's size, shape, and color. These observations are crucial for understanding how the storm evolves over time, offering a window into the dynamic processes at work on Jupiter. Here's a surprising tidbit. The Great Red Spot's influence extends beyond the atmosphere. It may also have effects on Jupiter's radiation belts, regions of intense radiation surrounding the planet. The storm's electrical activity and magnetic interactions might contribute to variations in the intensity and distribution of these belts, influencing the planet's overall radiation environment. Did you know that the study of the Great Red Spot has inspired creative pursuits as well? Artists and writers have long been fascinated by this colossal storm, drawing inspiration from its swirling beauty and mysterious nature. The Great Red Spot has appeared in countless works of fiction and art, symbolizing the grandeur and mystery of the cosmos. Finally, consider the storm's role in shaping our understanding of giant planets. The Great Red Spot serves as a natural laboratory for scientists studying atmospheric dynamics, providing a wealth of information about the processes that govern weather and climate on gas giants. These insights extend beyond Jupiter, informing our understanding of similar features on other planets, both within our solar system and in distant star systems. In contemplating these fascinating facts about the Great Red Spot, let your imagination drift across the swirling clouds of Jupiter, envisioning the timeless dance of this storied storm. Each fact we uncover deepens our appreciation for the complexity and wonder of the universe, reminding us that even the most turbulent phenomena can be sources of beauty and inspiration. As you gently drift into slumber, let these images of cosmic storms lull you into a peaceful dreamscape where the mysteries of the cosmos unfold in their quiet majesty. Let me share something intriguing about the size of Jupiter's Great Red Spot. Despite its massive scale, the storm has been shrinking over time. In the late 1800s, the storm was estimated to be around 40,000 kilometers wide, but recent measurements put it at about 16,000 kilometers across. That's still large enough to fit the entire Earth within it, but it's a significant reduction that scientists are keenly observing. Can you imagine this colossal storm disappearing one day? While it seems unlikely anytime soon, the storm's reduction in size raises questions about its future longevity and the atmospheric processes influencing it. This ongoing change adds a layer of uncertainty to our understanding of the storm's dynamics and longevity, keeping researchers interested in its fate. Speaking of which, did you know that the Great Red Spot is not just a lone entity? It is part of a larger system of storms and atmospheric features that interact with each other in complex ways. It's fascinating to think about the storm's interactions with Jupiter's jet streams and other atmospheric elements, as they all play a part in the planet's striking appearance and dynamic climate. Here's a detail you might find surprising. The Great Red Spot's winds are incredibly powerful, reaching speeds of up to 430 kilometers per hour. These intense winds are part of what allow the storm to sustain itself over such a long period. The winds create a high-pressure zone that stabilizes the storm, balancing the forces at play in Jupiter's atmosphere. Did you know that the Great Red Spot has a remarkable ability to absorb smaller storms? When these smaller vortices come into contact with the Great Red Spot, they can be engulfed and absorbed, contributing to the storm's energy and possibly even influencing its size and shape. This process is akin to feeding, where the storm gains strength and sustenance from its atmospheric surroundings. And here's something fascinating. The Great Red Spot rotates counterclockwise, completing a full rotation approximately every 6 days. This rotational period is different from other storms on Jupiter, which tend to rotate more quickly. The storm's unique rotation might be tied to its longevity, as it helps distribute the forces within and maintain the storm's stability. Speaking of stability, the Great Red Spot's height is also quite impressive. It towers above Jupiter's cloud tops, reaching heights of up to 8 kilometers. This vertical expanse means that the storm interacts with multiple atmospheric layers, each contributing different properties to its complex system of winds and clouds. Have you ever wondered about the temperatures within the Great Red Spot? The storm is surprisingly hot, with temperatures in the upper atmosphere reaching up to 1300 degrees Celsius. These high temperatures are a result of the storm's intense energy and friction, which create heat as a byproduct of the storm's powerful dynamics. Let me tell you about a curious phenomenon. The Great Red Spot glows in ultraviolet light. This glow is due to the chemical composition of the storm's clouds and is particularly visible in images taken by spacecraft. The glowing effect adds a layer of mystery to the storm, highlighting the unique interactions between sunlight and the chemicals swirling within it. Another intriguing aspect of the Great Red Spot is its potential for creating sound waves. The storm's violent winds and turbulence can generate acoustic waves that travel through Jupiter's atmosphere. These sound waves offer insights into the planet's atmospheric properties and can even help scientists understand the storm's internal structure better. Did you know that the Great Red Spot may be older than our first recorded observations suggest? Some scientists believe that it could have existed for over 300 years, based on historical records and observations of similar features. This immense age adds an element of timelessness to the storm, linking it to the longer history of our solar system. Here's a thought-provoking idea. The Great Red Spot's color changes could be linked to the seasons on Jupiter. As the planet orbits the Sun, its tilt and distance change, potentially influencing the atmospheric conditions and chemical composition of the storm. These seasonal variations might explain some of the shifts in color and intensity observed over time. Speaking of colors, the Great Red Spot's reddish hues are still a subject of scientific debate. While it's generally agreed that the color results from chemicals like phosphorus and sulfur, the exact process that creates the storm's vivid red tones is not fully understood. This ongoing mystery invites further exploration and investigation. Finally, consider this. The great red spot's influence extends beyond Jupiter itself. The storm might affect the orbits and dynamics of the planet's moons, contributing to subtle gravitational interactions that shape their paths around the gas giant. This interplay between the storm and Jupiter's moons emphasizes the interconnectedness of celestial bodies and the far-reaching impact of a single atmospheric phenomenon. As you reflect on these surprising facts about Jupiter's great red spot, let your imagination wander amidst the swirling clouds and powerful winds. Each fact reveals another layer of complexity and wonder, inviting us to ponder the mysteries of our universe and the forces that shape it. Let these thoughts carry you into a peaceful state of rest, where the grandeur of the cosmos soothes your mind and spirit. As you continue to drift through the gentle currents of knowledge about Jupiter's great red spot, imagine for a moment the sheer scale of this celestial storm. Did you realize that its size is so immense that it could comfortably fit 3 Earths side by side within its swirling expanse? This colossal dimension is a testament to the raw power and majesty of the gas giant's atmosphere. The enormity of the great red spot not only captures the imagination, but also highlights the dramatic forces that govern such a gigantic system. Now, here's something truly fascinating. The great red spot is thought to be gradually slowing down. Over the decades, data gathered by scientists have indicated a decrease in the speed of its winds. This deceleration might suggest that the storm is undergoing significant changes, possibly as part of its natural life cycle. It invites questions about how much longer the storm might persist and what new forms it could take in the future. And let me share another intriguing insight. The Great Red Spot is not just about winds and clouds. It has a distinct magnetic signature, revealing that magnetic forces play a role in its dynamic behavior. This magnetic aspect is largely invisible to our eyes, but provides scientists with a deeper understanding of the storm's interactions with Jupiter's vast magnetic field. It's a reminder that the storm is a multifaceted enigma, influenced by forces seen and unseen. Can you picture this? The Great Red Spot acts like a vast reservoir of energy. It stores up energy from its turbulent surroundings and releases it in the form of heat and motion. This energy cycle is essential for the storm's sustainability and helps explain its persistence through the centuries. The storm operates almost like a giant engine, perpetually driven by the immense forces of Jupiter's atmosphere. Here's a curious tidbit. The Great Red Spot's shape is not constant. Over time, it has changed from an oval to a more circular form and back again. This morphological evolution is driven by the dynamic forces at play within the storm and its interactions with neighboring systems. The continuous reshaping of the Great Red Spot adds to its mystique as it adapts to the shifting conditions of its environment. Think about this. The Great Red Spot's height is not uniform. It fluctuates due to changes in atmospheric pressure and temperature, causing the storm to expand and contract vertically. These changes can provide clues about the atmospheric conditions on Jupiter and the storm's potential future. The vertical dynamics of the Great Red Spot highlight the intricate relationship between different atmospheric layers, each influencing the others in complex ways. Speaking of relationships, have you ever wondered about the Great Red Spot's interaction with Jupiter's jet streams? The jet streams are powerful, fast-moving currents of gas that flow through the planet's atmosphere. The Great Red Spot and these jet streams are locked in an intricate dance, with the storm influencing the flow of the jets and vice versa. This interplay is a major factor in the storm's longevity and behavior, as it both shapes and is shaped by the surrounding atmospheric currents. Now, let me tell you about a rather unexpected fact. the Great Red Spot might produce lightning. The storm's intense turbulence and energy are believed to create conditions conducive to lightning generation. While direct observations of lightning within the Great Red Spot are challenging, the possibility of electrical discharges adds another layer of activity and intrigue to this already complex system. Another surprising aspect of the Great Red Spot is its role as a potential heat source for Jupiter's upper atmosphere. The storm's persistent activity and energy release could contribute to warming the surrounding areas, influencing the overall thermal structure of Jupiter's atmosphere. This heating effect could have far-reaching implications, affecting everything from atmospheric circulation to chemical reactions across the planet. As we contemplate these mysteries, consider the idea that the Great Red Spot might not be the only enduring storm on Jupiter. There are other long-lived vortices that share some characteristics with the Great Red Spot, though none match its size or prominence. These smaller storms hint at the larger patterns and cycles governing Jupiter's atmosphere, providing a broader context for understanding the planet's climatic systems. And here's a final thought to ponder. The Great Red Spot may hold secrets about the formation of planets in our solar system. The storm's longevity and complexity offer hints about the early processes that shaped Jupiter and other gas giants. Studying the Great Red Spot could, therefore, reveal insights about the primordial conditions that influence the development of our planetary neighborhood. As these details swirl around you, let the majesty of Jupiter's Great Red Spot inspire a sense of awe and wonder. This extraordinary storm, with all its surprises and mysteries, invites us to look beyond our world and ponder the vastness and complexity of the universe. Let this contemplation guide you into a tranquil slumber where dreams of cosmic exploration and discovery await in the peaceful depths of the night. Have you ever considered that the Great Red Spot might have its own unique weather system within it? Just as Earth experiences weather patterns that can be distinct from one region to another, this massive storm can harbor its own mini-storms that swirl and churn within its boundaries. These internal disturbances are like weather within weather, adding layers of complexity to the storm's already intricate dynamics. Imagine standing at the edge of such a tempest, witnessing the smaller vortices dancing within the larger system, each contributing to the Great Red Spot's overall energy and behavior. Speaking of energy, did you know that the Great Red Spot might actually be a source of sound? Some scientists speculate that the storm could produce low-frequency sound waves, inaudible to the human ear, as a result of its immense energy and turbulence. These acoustic waves could carry information about the storm's internal processes, offering yet another avenue for researchers to explore the secrets of this planetary giant. It's as if the Great Red Spot was playing its own symphony, a silent but powerful composition that echoes across the Jovian atmosphere. Now, here's a curious observation. The Great Red Spot appears to change color over time. While it is famously known for its reddish hue, this coloration can vary from deep crimson to pale orange. The reasons behind these shifts are still not fully understood, but they might be related to chemical changes in the storm's atmosphere or variations in the sunlight it absorbs. The color changes of the Great Red Spot serve as visual clues that scientists can use to infer the chemical makeup and environmental conditions at different times. Imagine the storm's size once again. At its most expansive, it could fit 100 Earths inside it. This means the Great Red Spot is not only longer but also dramatically broader than our entire planet. It's a striking reminder of just how small we are compared to the vastness of Jupiter and the incredible phenomena taking place there. This sheer scale challenges our perceptions, and invites us to consider the possibilities of other wonders hidden within our solar system. Interestingly, the Great Red Spot seems to have a cycle of shrinkage and expansion. Over the past few decades, scientists have observed a trend where the storm's size appears to be gradually diminishing. However, this shrinkage occurs in a manner that suggests cyclical behavior, hinting at possible expansion phases yet to come. It's a bit like watching the tides ebb and flow, a natural rhythm that adds to the storm's intrigue and mystery. And here's another fascinating aspect. The Great Red Spot's influence extends beyond the clouds. It affects the dynamics of Jupiter's deep interior as well. The storm's immense gravitational pull and energy could potentially impact the planet's internal structure, contributing to shifts and changes far beneath the visible cloud tops. This deeper connection between the storm and the planet's core offers scientists a rare glimpse into the hidden workings of Jupiter's vast innards. Speaking of hidden workings, did you know that the Great Red Spot might be a source of auroras on Jupiter? Just like Earth's auroras, which are created when charged particles collide with the atmosphere, Jupiter's auroras could be influenced by the storm's magnetic interactions and energy outputs. These auroral displays, visible at the planet's poles, could have a connection to the Great Red Spot, linking the surface chaos to celestial light shows high above the Jovian clouds. Another intriguing thought is that the Great Red Spot might be contributing to atmospheric waves that ripple across Jupiter. These waves can travel great distances, carrying energy and momentum through the planet's atmosphere. The storm's powerful winds and turbulent motion could be a driving force behind these planetary-scale waves, which play a crucial role in Jupiter's overall atmospheric circulation and weather patterns. It's a bit like casting a stone into a pond and watching the ripples spread outward, a dynamic dance of forces that influences the entire system. Here's something to ponder. The Great Red Spot might have layers, much like a giant atmospheric cake. Each layer could have different temperatures, pressures, and chemical compositions, contributing to the storm's complex behavior. By studying these layers, scientists hope to unravel more about the processes that sustain and drive the Great Red Spot, as well as how similar storms might operate on other gas giants. Finally, let me share a whimsical thought. Some scientists theorize that the Great Red Spot could potentially harbor life, albeit in a form vastly different from anything we know. This speculation arises from the possibility that the storm's chemistry and energy might create conditions suitable for microscopic life or unique life forms adapted to Jupiter's extreme environment. It's a far-reaching idea, yet it underscores the imaginative scope of scientific inquiry and the wonder of the unknown. As you drift into a peaceful slumber, let your thoughts wander to the Great Red Spot and the many mysteries it holds. Consider the profound beauty and complexity of our universe, where storms of unimaginable scale rage on distant worlds. Allow these gentle musings to lull you into a dream, where the wonders of space unfold around you night after night, opening doors to endless exploration and discovery.